Hello. Let's go ahead and use our special right triangle tools. So, square, diagonal, 3 roots of 2, divide by root 2, and the area is just 3 times 3. Equilateral triangle with height of 8 root 3. To go down there, I'm going to divide by root 3. And what do I want to do? Find the area. So I have 8 root 3 times 16 divided by 2, which gives me 64 root 3. Now let's try some more special right triangles. So what do we have here? To go from here to here, I'm going to divide by root 3, which gives me root 7. And then I'm going to multiply by 2, which is 2 root 7. I go through why that's true in worksheet A, so if you need help, look at that. To go from here to here, I'm getting bigger, I am multiplying, and the magic number is root 3, so this times root 3 is root 15. Here I'm getting bigger, and magic number is 2, because it takes 2 of those to make one of those, and so that would be 2 root 5. To go from here, I'm getting smaller, I am dividing, and I am dividing by the magic number root 2, which gives me root 3. And here I am dividing by root 2. I do need to rationalize my denominator, which gives me 10 root 2 over 2. When I reduce that, I get just plain old 5 root 2 for both of the answers. Alright, let's go ahead and look at these. We did some of these in class, but in order to get to this height for the area of the triangle, it's going to be 1/2 of the base times the height, and the height is going to be the sine of 20 is equal to the height over 7. So the height is 7 times the sine of 20. For this one here, I'm going to do 1/2 of the base times the height, and the height here is going to be sine of 70. Again, we're using sine, equals h over 5. So the height is equal to 5 times the sine of 70. And our last one here, to find, it's going to be 1/2 of base times the height. And the height, again, is sine of 40 is equal to h of over 9. So that would be 9 times the sine of 40. Now, each of these, if you look at it, is SAS, SAS, SAS. So this very, very special case scenario, it appears to be that it's half of the base times, actually look at a triangle. If I had that this was angle C, and this was side A, and side B, we're saying it's 1/2 of the bottom, and then this is always the other side times the sine of the angle, the other side times the sine of the angle, the other side times the sine of the angle. So we're going to have the other side times the sine of the angle. So 1/2 AB sine C works out real nice.